Hello everyone. In this video we're going to be solving a geometry puzzle. Four circles with radii A and B with A less than B are inscribed in a square as shown. Find the ratio A to B. Alright, at this point, if you want, pause the video, try this problem and then watch the rest. Or you may continue to watch it. Alright, let's get started. Now, the only thing we know is that the radii are given basically A and B, and A is less than B, so the red circles are smaller and their radii is A, or their radius is A, and the green circle comes with radius B. So let's go ahead and make some connections here, right? Okay. And another thing we know that they're inscribed in a circle. Square. It's not given, the side length is not given, but I guess that's not going to change the ratio, right? Okay, let's proceed. What am I going to do? Well, I'll be connecting the two centers here. Let's go ahead and start with that. So if you go ahead and draw a straight line here like this, okay, I can make that connection. Kind of goes through the center or where the circles touch each other, right? And then I would like to make this connection. That will also help, I think, right? There we go. And then what else can we do? Well, we need to take advantage of the fact that the radii are given, right? So let's go ahead and make more connections. Obviously, this is A, right? And I probably want to change it at this point. I don't want to write like that. Well, maybe making all the connections and then I'll just switch around. Okay. So let's connect these as well. I think this is going to be very critical, don't you think? Uh-oh. We gotta back up a little bit. Okay, here we go. So this connection is going to be crucial because it's basically connecting the two centers, right? That's very important. As you know, if two circles are tangent, always make sure to connect their centers because that's going to give you a good amount of information. Awesome. Let's see what we have here. So we do have a right triangle, looks like, right? This should be a right triangle. Okay. And we know that this is A, so let's change our pen here a little bit to a normal one, right? Okay. Here we go. And we might just pick a color as well, right? Here we go. Okay. So this is supposed to be A, right? A is less than B, it's given. This is B. This is also B. And this is also A. But I'm not really interested in that length because what I want to find is actually the height of this right triangle. What's the height? Let's call that H. Okay. Awesome. If that's H, how can I proceed? Well, we do have a right triangle here, right? Don't we? Okay. Obviously, this is right triangle. And I can just go ahead and write the Pythagorean theorem, right? Okay. We can do that. Yes, let's go ahead and do it then. So this gives us the following. Okay. I have b squared plus h squared, which equals a plus b quantity squared, right? That's the hypotenuse. Awesome. Okay, how am I going to proceed? Well, we're going to expand the right-hand side, right? b squared plus h squared is equal to a squared plus 2ab plus b squared. All right, what am I going to do from this point on? I'm going to simplify this. How do you simplify this? Cancel out the b squared, and you end up with hopefully something nicer. Well, at least we are able to write h in terms of a and b. So what is h? H is equal to the square root of a squared plus 2ab. Awesome. And remember, a and b are the radii, and we're supposed to find the ratio. How is that going to help us? Okay, let's see. Let's watch and see. So I was able to find h in terms of a and b. Great. What else can I do? Well, I need to do more than this, right? Obviously, because I do need the side length for the square. Do I have it? No, I don't. Maybe we can call that x, right? If you call that x, then it's just going to be x, unknown, right? Is that going to help? Not really. But at least it's going to help us come up with some equations. So, if the side length for the square is x, And I can also work with a quarter circle here, but you know what? I'm just going to work with the whole thing because I just like to do it that way. So I'll be marking more lengths here. Let's go ahead and do that. This is also B. This is also B. And this is also B. What is that supposed to mean? Wow, B plus B plus B plus B is equal to the side length for the square. Beautiful. B for beautiful, right? Okay, so the side length for the square, in other words, is 4B. Okay, cool. So what about that? It's not going to help me find the ratio, right? I still don't know the side length, so what am I going to do? But think about this. You can write the side length in different ways. How? You can write it horizontally and you can write it vertically, right? How do you write it vertically? Let's mark more lengths here. So this is supposed to be what? A. This is supposed to be A. What about this piece? From symmetry, it's also going to be H. Beautiful. Then the side length for the square, if I call that X, this whole thing here, if I call that X, then X can be written in two ways, and hopefully that can help us. But don't lose sight of the fact that we're trying to find the ratio A over B. That's our goal. Okay, so let's go ahead and write down our equation here. We have X, which is the side length for the square, which is equal to 4B. Okay, it's not 2B, so I can't make that joke again, right? 2B or not 2B. It's 4B. Then I can also write it this way, right? This is also X, isn't it? This is also X, isn't it? Yes, it is. But what is X equal to? If you write it that way, it's A plus H plus A plus H, or 2A plus 2H. Beautiful. 2A plus 2H. Does that help? It is going to help us. Okay, now you can totally forget about the X. We're not interested in finding X, right? And we can't find it, obviously, because A and B are not given. But hopefully we can find something from here. So ignore the X and focus on the rest. But I know that H was written in terms of A and B, right? I'm glad I have that. But can I do something? Even though I said that I was going to work with the whole square, I can now cut everything in half. That's going to be nice. You'll agree with me on that, I believe, right? So now let's go ahead and replace H with what it is. What is H? H is equal to this. Square root of A squared plus 2AB. Awesome. Is this awesome? Well, you might be looking at this equation and like, what is going on here? Okay, what are we trying to find? We're trying to find the ratio A to B. Can we find A over B from here? We gotta give it a try, right? Okay, what can I do if I have a radical in my equation? What is the best approach? Well, you've seen in many examples, we've done a lot of quadratic equations and radical equations. We try to isolate the radical, right? That's our first step. So isolate the radical. It just likes to zoom out and zoom in. Okay, isolate the radical, and then you know the next step, don't you? The next step is going to be squaring both sides, because that's going to help. Okay, that's why we're isolating the radical. If you square both sides without isolating the radical, you're going to run into difficulties, such as you're going to get another radical, and then if you never isolate it, you'll keep getting radicals. Okay, they're just going to grow and grow. You might do that for other purposes, but for our purposes, we want to get rid of all the radicals. You want to get a nicer equation. Okay, let's proceed. What am I going to do next? My next step is going to be squaring both sides. That's why I wanted to get the radical by itself. Okay, let's proceed. Square the left-hand side, you get 4b squared minus 4ba, or I like to write 4ab, plus a squared. That's a perfect square. You know the formula, you know the drill. Okay, now I have something under the radical being squared. The radical disappears. I end up with a squared plus 2ab. Awesome. What am I going to do from this point on? Well, take a look at it carefully and notice that a squared cancels out. Isn't that nice? It's absolutely nice. So let's go ahead and do that. And then should we just start adding stuff and then canceling out? No, no, no. If you're trying to solve for something, do not cancel a variable unless they're being added or subtracted, like in the case of a squared. But if something is multiplied, let's say you have an equation like this, okay? 3x equals x. What happens if you cross out the x's? 3 equals 1. Beautiful. We proved that 3 equals 1. We can prove this for many numbers, but that's not true. This is false, right? You're supposed to put everything on the same side. You can't just divide by x, especially if x is 0, right? Division by 0 is not allowed. So what I'm going to do here is then bring the 2ab over here. 4ab and 2ab are like terms, so they like each other. That gives me minus 6ab, and the whole thing is equal to 0. Beautiful. When you get a 0 on one side of the equation, it's always nice. Well, most of the time. So remember, again, what's our goal? Our goal is to find what? A over b. That's what we're trying to do. Can we find a over b from here? Let's proceed. What are we going to do next? Well, factoring. Is this expression factorable? Yes, because there are two terms and there's a common factor. What's the common factor? The common factor is 2b. Haha. 2b or not 2b. Okay, that's the point. So you can take out the 2b, and then inside you'll find 2b minus 3a. Beautiful, beautiful, beautiful. Okay. Okay. That was a song, right? Beautiful, beautiful, beautiful angel. Anyways, we're not going to sing here. This is a math video, right? Okay. So what am I going to do? Well, I'm supposed to solve for a over b. Can I do that here? Obviously, b does not equal 0, right? Well, it wasn't given in the problem. Well, there was a circle, right? So it has to have a non-zero radius. Come on. So b does not equal 0. Forget about that. So this guy over here needs to equal 0. Awesome. What does that mean? It means that 2b, oh man, 2b or not 2b is equal to 3a. Well, I'm trying to find a over b. So one of the things I can do is I can divide both sides by b. Awesome. Let's do that. And then from here I get, oops, I messed up. Okay, from here, what am I getting? B cancels out, and I get 3a over b is equal to 2. Then I can divide both sides by 3, and I should be getting a over b as 2 over 3. So that's the ratio we've been looking for. Now go back to the problem and see if that makes sense to you. Well, if you consider these lengths, yeah, I think if a is about, like if a is 2, b can be 3, yes, and it's drawn to scale for sure because you have a really nice picture here, don't you? Okay, it works. So the answer is 2 over 3. That's the ratio we've been looking for. And again, this does not depend on the side length of the square. You can make it real large, you can make it real small, but the ratio is not going to change. That's it for this video. Thank you for watching. Don't forget to comment, like, and subscribe. And I'll see you in the next video. Until then, take care, be safe, wear your mask, and be good. Bye-bye.